Hi guys, this is O-Level Chemistry, paper 11, June 2022, question 31. Which gases are used in light bulbs? So light bulbs have inert gases present in them. So one, argon, yes, it's a noble gas. Oxygen is a reactive gas, so no. Neon again is a noble gas, so yes. So this makes uh, choices 1 and 3 correct, which results in option C being the correct option for this question. Question 32. The carbonates of metals W, X, and Y are heated and the results are shown. Okay, let's look at the results. Color of the metal carbonate. W is white, X is green, Y is white. Okay. Gas given off which turns lime water cloudy. W and X, yes, and Y is no. So basically, the gas given off is CO2. So carbonate is present in W and carbonate is also present in X and carbonate is absent in Y. Color after heating, yellow when hot, white when cold. Okay. Next, X, color after heating. A carbonate which is green in color which turns black after heating. This could be copper because when you heat copper carbonate, it forms copper oxide and copper oxide is black in color. That is how I came to this conclusion. Next, a white metal, the anion is unknown and color after heating, there is no change in the color of this salt. Okay. These experimental results can be used to write statements about W, X, and Y. Okay, let's look at these statements. The carbonate of W and X, okay, they mentioned carbonate, gave off carbon dioxide on heating. Yes. Metals X and Y are less reactive than metal W. The tests carried out lack evidence of reactivity. So this statement lacks evidence. X could be copper. Yes, X could definitely be copper because copper oxide is black in color. So out of the given options, 1 and 3 are correct, making option C the correct option for this question. Question 33. The diagram shows an experiment to determine the percentage of oxygen in air. Which diagram shows the correct level of water after candle stops burning? So oxygen in air. Air contains 21% by oxygen. Okay, which diagram shows the correct level? So if the oxygen in air is used up, then the water will rise in the bell jar. In A, the water level has dropped below the water level of the beaker. So this does not happen ever. Next, in B, the water level remains the same. That means oxygen was not present. So this is also wrong. In C, the water has risen up, but this is almost 20% of the total volume of the bell jar. So this is very close to 21. This is correct. And in D, we have 50% of the jar filled with water and 50% of the jar filled with air. This would show that air contains 50% by volume of oxygen, which is wrong. So this makes option C the correct option for this question. Question 34. Two statements are given. Statement 1, the percentage of carbon by mass is greater in methane than in butane. Okay, we'll need to calculate this then. So in methane, CH4, the percentage of carbon by mass. Carbon is 12, overall mass of methane is 16, so 12 upon 16 into 100 will give us a percentage of 75. And in butane, butane is C4H10. So this would give us 12 fours of 48 in the numerator plus 10 makes it 58 in the denominator into 100. This would give us 82.76% in butane. And the statement says the percentage of carbon by mass is greater in methane than in butane. So this statement becomes incorrect. Statement 2. Butane is one of two isomers with a molecular formula C4H10. Okay, molecular formula C4H10, it is one of two isomers, butane. So CH3, CH2, CH2, CH3. This is butane itself. And if we make an isomer of butane, we shift the position of one of these carbon atoms, and the only place that carbon atom can be placed is here. And this compound that is formed is called 2-methyl propane. There is no other isomer of butane that is possible. So statement 2 is correct. Now let's look at the options given. Both statements 1 and 2 are correct. No. 1 is wrong, 2 is correct. Statement 1 only is correct. No. Statement 2 only is correct. Yes. Neither statement 1 nor statement 2. No. So this makes option C the correct option for this question. Question 35. 1 mole of each of the compounds shown is completely combusted. Okay. How many of the compounds need exactly 9 moles of oxygen for complete combustion? Now, let's label these 1, 2, 3, and 4. In 1, we have got C5H12O. So let's use the general combustion equation to solve this. X is 5 and H is 12. So the moles of oxygen would be X plus Y upon 4, right? So 5 plus 12 upon 4. 12 upon 4 is 3 plus 5 is 8. And we have 1 mole of oxygen here. So we subtract half from 8, which gives us 7.5 moles of O2. This will give us X moles of CO2. X is 5 in this case, so 5 moles of CO2, and Y is 12. So 12 upon 2 is 6. 6 moles of H2O. So C5H12O does not require 9 moles of oxygen. Next, C6H12. So C6H12, this is a pure hydrocarbon. So 6 plus 12 upon 4. 12 upon 4 is 3. 6 plus 3 is 9. 9O2. This will give us 6 CO2 and 6 H2O. So C6H12 is correct. So this is the first molecule that requires 9 moles of O2. Next, C6H14, another alkane. C6H14, also a hydrocarbon. So 6 plus 14 upon 4. Now 14 upon 4 will give us a value of 3.5. So 6 plus 3.5 is 9.5 O2. So this will give us 6 CO2 and 14 upon 2 is 7 H2O. So the value for nitrogen, the moles of nitrogen is 9.5 and not 9. So this is incorrect. Let's look at the last option, C6H14O. Now, the good thing is that we have already covered C6H14 above, right? So this required 9.5 moles of O2. Now, one oxygen atom is present in the compound itself. So one oxygen atom being present here results in half being subtracted from x plus y upon 4. So x plus y upon 4 is 9.5 in the above example. When we subtract half, we end up with 9 moles of O2, giving us 6 moles of CO2, and 14 upon 2 is 7 moles of H2O. So this is another molecule which requires 9 moles of O2. So in total, we have two molecules that require 9 moles of oxygen, making option B the correct option for this question. Question 36. The reactants and products of two reactions are shown. Okay. Reaction 1 is C3H6. C3H6 is an alkene. When it reacts with water, this will form C3H7OH, an alcohol. And in the next example, X reacts with oxygen forming CO2 and H2O. Since we have 1 mole of CO2, we have one carbon atom present in X, and we have 2 moles of H2O, so we have 2 hydrogen atoms present in X, and the product contain total 3 moles of oxygen, and the reactants have 2 atoms present in the form of a molecule. So one oxygen is missing, so that oxygen will also be part of X. So X is CH2O. Now the question, which row correctly describes these two reactions? Identity of compound X, butanol or propanol? So butanol would be C4H9OH, which would be C4H10O. So there is no empirical formula for this. The molecular formula is the empirical formula for butanol. Whereas for propanol, it would be C3H7OH, which is converted into C3H8O. Again, this will not be converted into a different empirical formula. So identity of compound X. So we will need to see what this converts to. Identity of compound X. The reactant products of the two reactions are shown. Which row describe these two reactions? Okay. So next, conditions for reaction 1. Condition for reaction 1 is heat and catalyst. So option A has been eliminated. Reaction 2 is combustion. So options 2 and 3 have been eliminated, B and C. So combustion is there in option D, which makes this compound as propanol and not butanol. So based on the empirical formula given CH2O, we were unable to select the alcohol because butanol and propanol both had only one oxygen atom present, so their molecular formula was their empirical formula. But the conditions of each reaction gave us the identity of the alcohol. So this makes option D the correct option for this question. Question 37. Which statement about carboxylic acid is correct? All carboxylic acid includes the group COOH. Yes, this is the functional group. B. Ethanoic acid reacts with both copper 2 oxide and copper. No. Ethanoic acid is a weak acid. Methanoic acid formed by bacterial oxidation is present in vinegar. Vinegar contains ethanoic acid, not methanoic acid. D. Propanoic acid decolorizes acidified potassium manganate. That means it undergoes oxidation. Carboxylic acids do not undergo oxidation. So B, C, and D are incorrect, making option A the correct option for this question. Question 38. The structure of an ester is shown. What is the name of this ester? Okay. So name of the ester includes the name of the alcohol and the name of the carboxylic acid. The carbon with the double bond O is part of the carboxylic acid, and the carbon attached to single bond O is part of the alcohol. And the name of the alcohol is written first. So in this case, we have got 3 carbon atom in the alcohol portion. So this becomes propyl. The name begins with propyl. And we have 4 carbon atoms in the carboxylic acid portion. So this becomes butanoate. So the correct answer is propyl butanoate, which is option C. Question 39. Polyethylene is formed by polymerization of ethene, addition. So A, B, and C are correct. D has been eliminated. Next, the formation of nylon and terylene are examples of dash polymerization. Condensation. Again, A, B, and C all contain condensation. Next, proteins contain the same dash linkage as nylon, amide linkage. Proteins are polyamides. So A and B contain amide, C contains ester, C has been eliminated. Continuing on. Fats contain the same dash linkage as terylene. Terylene contains an ester linkage, so fats will also contain an ester linkage. Both A and B have ester linkage present. So both will continue. On hydrolysis, proteins form dash. Option A says amino acids. Option B says simple sugars. Proteins are polymers of amino acids. So option A has all the correct answers, making option A the correct option for this question. Question 40. The repeat unit of a polymer is shown. Which monomer would produce this polymer? Now, since all the options have a double bond present, we can easily work out the monomer because in addition polymers, the double bond opens up. So, carbon-carbon double bond is present. In the carbon atom on the left, we have got a CH3 group and a hydrogen atom present. And the one on the right has a chlorine and a bromine group attached to it. Okay. Now, we have option A, the carbon on the left having hydrogen and CH3. This is correct. And the carbon on the right having chlorine and bromine. This is also correct. So option A is the correct option. Option B, we have CH3 and H on opposite, or rather not opposite, different carbon atoms, chlorine and bromine on different carbon atoms. So wrong. C also have the same configuration of atoms or side groups. This is also wrong. D also has this thing, but in D, if you can see, chlorine and bromine are on opposite carbon atoms, but also placed on opposite sides. And same thing with CH3 and hydrogen. So this makes option D incorrect as well. So we have already figured out the correct option for this question is option A.